Okay, so last time we're working we're working on the fourth. But yeah, fourth. Where's fourth? And I didn't record, unfortunately, but I didn't finish either. So this is where we're at. Oh, actually, it's just the test cases, and we have this. So with this fourth, we pass some test, but we fail most of the definitions. So to recap, what I've done is they ask us to write an eval function, which takes an input string, and that should return a result, which is either fourth result. It's either nothing, unit, or it's an error. Surprisingly, there's also a function that returns the content of the stack. So that, I guess that's what the test is going to verify. That's how I'm guessing. I saw it. The test is going to verify the stack content. And so that function here for us it's really going to just return a copy of the stack. So our fourth interpreter is a stack, which is implemented as a vector of values, I32 here, and then there's a hash map where we keep the definitions of the user-defined expressions. So when we create a fourth interpreter, we initialize the stack to an empty vector, and our definitions is an empty hash map. When we want the stack, we clone the stack and we return it, because we want to keep ownership of our own stack. The big function is eval, obviously. And what I've done here is pretty typical parser logic implementation. So we start by splitting the input based on spaces. So for a more more advanced language, that would not be enough, because everything is not separated only by spaces. But in our case here, space is the only acceptable delimiter, separator. So we can split on that and collect the tokens into a vector of strings. Then afterwards, it's a matter of going through these tokens and then making some action. There's essentially two behavior, or two mode, I would say. One is when we are executing a program, and the other mode is when we are storing or handling a word definition. So the syntax is that it has to start with a colon, and it has to end with a semicolon. So and I don't think they're allowed to be nested. So this really has to be this way. So we mark we keep the mode in this variable. Def start is pretty bad mode. Okay, let's call it def mode, definition mode. So we start in evaluation mode. So definition mode is false, and this guy here is going to store our current definition. Alright, so we look for the tokens. If the token is empty, it just means that the string contains multiple spaces in a row. so we don't have to do anything. We just go to the next token. Otherwise, we capitalize it because our stock is case insensitive. So we always capitalize the word. And then if it's not in the definition mode, so this is actually a common code path, we can have switch a match on that token. And we have several implementations here. So for dupe, we call dupe. For these keywords here, we are simply going to call our implementation of these stack manipulation functions, which are right here. And then for integer arithmetic, they are handled as this bin operation. So I use a closure so that I wouldn't have to repeat the logic of a standard like a classic binary operation, and the closure specifies the operation performed on the two numbers. So for plus, we will do I plus b and so on and so forth. Only trick here is that if you have a division and b is 0, we have to return an error division by 0. Other than that, it's pretty standard. Then we handle the semicolon to switch into definition mode. And the last case is if it's a number. So if it's a number, then we push the number into the stack. If it's not a number, then it should be one of the user defined symbols. For this case, we look into our definition hash map, and if the word is known, right, then we evaluate it. So this bar is wrong because I just saw by looking at the okay, may not be wrong, but I just saw by looking at the test cases that the way I implement this part is not what they expect. So we're gonna have to change maybe this part. Other than that, the stack manipulations are we treat our vector as a stack, so we have to use the push and pop methods. And other than that, it's pretty standard. It's pretty simple. If the stack is empty, we cannot dupe it. But otherwise, we take the last element and then we push it. Drop means we pop the last element if it's not empty, the stack is not empty. Swap would be swapping if we have at least 2 items. And then over means that we're duplicating the it's like dupe, but not with the last element, it's the one to last. So actually here I think it's gonna be done better because I'm actually popping 2 elements and pushing them back. So I guess we could do it this way, but instead of using last, we do len minus 2 because we have a stack, so it's or we have a vector, so it's random access. Okay, so this guy is suspicious. Will probably be improved. Binary operation, pop 2 elements and then use the closure to evaluate and push back the result. And our test for number, so everything is an integer here, so all I do is I make sure that everything is a digit. Okay. So actually I'm not sure, I don't think this guy is very good because I think we can try to parse like this one, token parse, and it will return yeah, it would, if we just parse the guy and it returns some value, then it's good. Because we don't handle the case where the number is too large. But there's no error for this. There's no in this specification. They don't say what we should do if we have a number which is actually too large for I32. So I'm gonna leave it like that. All this stuff works except for the definition mode. So to conclude with definition mode, once we have this semicolon, we switch to definition mode, and that means that we are going to look for the word name, which is the name of our new definition, and then a bunch of tokens, and then finally a semicolon. So if we see a semicolon while we are in def mode, then that marks the ending. So we can close it, we can disable it, unset it, and this stuff is fishy, because today or currently I just store everything that was defined, all the words, into this definition. So definition is the name of the word, and then a series of tokens. Okay, and if we don't have a semicolon, but we do have the name, so this says that our definition it exists, right? So first we start with def mode equal true, but we haven't seen the word name yet, so we don't have def is still known, and once we see that name, we create some definition, and when we set it to def. So actually the logic is first this guy, then this guy, and then this guy. Right, it's a bit weird, other way around. Actually, I could shuffle this. So first time around it should be this guy. So we test that the token should be a word, should not be a number. And then we set it to that definition. The tokens is empty. Then afterwards we push these tokens inside, and then finally we close it here. Okay, so and when we close, we store the definition into our hash map. Yeah. So I think the trick here is that when we actually evaluate our user word, we are using eval recursively, right? So but essentially we expand the user definition, and we use it our evaluator on top of that. So the argument should be a string, and currently we have it as a vector of a vector string. So each word is being parsed separately. So in itself is not too bad, because we could always say that at the end we collapse all these guys together. But we could also simply make the definition a string and append. So let's try that. So this is word and this is definition, which is also a string. They call it definition, right? And that means that this guy is going to change, right? When the definition is created, we have it as an empty string. Right. And then when we see token, we are going to append it. But actually, if the token is it's also a user definition. We should replace it with the definition. Alright, so um, let's see if we can do okay, so this will be self-defs, and we are getting the token. Alright, so mismatch expected reference. Okay, so I'm doing this, and that returns an optional definition. So if it's one thing they're going to test is whether the definition is using one of those keywords. These guys, but we can do that later. Okay, so D is an option, and so if let's do a if let D, this is sum D, so this match is an actual definition. Then we're gonna push the content into our token definition, right? So def plus equal with the white space and our D. Okay, that D doesn't like D dot definition. All right, so that's probably a string with a okay, yeah. Well, okay, we could leave it as a vector of string and then definition because basically, oh, okay, whatever. Let's pick a string. The only thing here is that I actually want to have. Okay, let's do a format, even though it's probably a bit of overkill. Right, so this adds the expansion of our guy into this, and otherwise this is not a definition, so we just add that token. Maybe we just can do like, okay, let's add the space first. Alright, and then we can add that guy. This way we can okay, they didn't like that part here, right? But let's add the token. Alright, so what's the problem? Found string expected str. Can I do this then? Yeah. Right. And the problem here is that we want to evaluate on definitions. Alright, it's a move somewhere, yeah. Okay, so we have to. Right. Oh, something's wrong here. Cannot borrow self as mutable because it's also borrow immutable. Oh, sorry. 19 is a mutable borrow. Oh, def is the one where we have. Okay, that's def. Oh, so hot in here. So what's the problem? So def is Yeah, f is borrowing, def is borrowing self, because we're getting the word definition, and now we can't do this. We have to release that guy. So one easy way is to make a copy. Def definition. Alright. Now obviously this is not gonna work because we have to clone the guy, and now we can use it here. Okay, so that works. Alright, we even have more problems now. Error, malformed word definition case insensitive. Okay, so okay, let's see. Let's see one at a time. Left, okay, left is what we should have, and right is what we got. Okay. Okay, malform. Okay, so this one is oh, it's not closed. Oh, it's because it's not closed. Okay, so I'm guessing you also want to make sure that at the end of evaluation we are not still in the middle of this stuff. So that's actually here. If in so def mode should be false. Invalid word? I think it's invalid word. Okay. So this one we didn't test, and this one we didn't test. I don't know if this is allowed or not. This one we should pass. Kai is insensitive. Okay, it's insensitive. Okay. So food up and can be used as foo. Oh, okay, that's weird. Because I thought we were capitalizing everything. Okay. So why? I would like to know what's the content of our hash map. Definition doesn't implement debug. Why should? Okay. Huh? Why no message? Something about capture. Okay. Failures. Definitions are case sensitive. Okay. We have bar. My foo. Okay. Foo bar. What do we have? Okay, let's just see this one. Comment this guy. Okay. No capture. Who dip? Who dip? Who dip? Okay. But it seems correct. One swap is okay. Okay. One swap. Okay. Swap dip dip dip. Oh, you can redefine this guy? I'm confused. Can you? Okay, you not define well. Oh, you can. Oh, okay. Oh, that just means that this guy should be up there. Alright. This guy should be up there. But it's only if contains key word. Right, so we have to take this guy up there. Okay, if the guy contains the keyword, might as well unwrap it here. And other than that is this unknown word. Okay, this guy is come here, and now we unwrap. Yeah, everything passes. Okay, so if you want to be a bit picky, we can just do this one. Well, this is not so important, I guess. Okay, so that's it. And I think there was the last exercise. Oh, in the hard level. Oh no, there was not one more. There is one more. Why so? I see. Define execution insert. Where execute? Where do you actually define? path string. Path string as occurs. Next. Not sure understand. I don't understand how he finishes. Oh, he was one. Okay, so path string. Okay. I see. Okay. Inner, what's inner? Inner split. Red. Okay. Not super clear. What about this one? Oh my god, this is worse. Okay. Okay, well, I think I'm okay with my version then. For the most part. Okay, so what else do we have? Double linked list. Why is unsafe? Okay, I don't think I'm gonna do the unsafe guy because I think unsafe is well, it's not in my it's not really why I'm interested in Rust. I guess eventually I may have to use it, but I don't want to get into this kind of habit so early. So I think I may do the medium ones. There's a bunch of them though. Okay, let's take a break. Let's take a break and see, reflect on what we learned so far.